Hello everyone. Today we will talk about collections. Collections help us organize the program state and the program data. It is very important to be familiar with the available collections and to know which one to choose based on the problem that you are trying to solve. We will start with arrays. So let's say we have an int variable name num1. Now maybe we need to have 10 numbers, so we can declare 10 different variables. It will be very difficult to work with these variables. Let's say that we want to log all the values, so we need to write and start duplicating our code. When you duplicate your code, it is always a good sign to know that you are doing something wrong. So instead we will create an array. And here we set the number of elements, let's say 10, and the type. We can access an element like this. Always remember that whenever there is an index in before x, the first element index is 0. This means that the last element is length -1. So let's print all the array elements. 0, 2, length -1, and we can see it over here. We don't need them anymore. Better option to iterate this way. We don't need to remember to subtract 1 from the length, and it is safer. Another way to create an array and to set its element is with the array keyword. Array as int and it prints 1 to 5. Note that the array keyword returns a new array. The previous one was discarded. Instead of writing 10 here, which is just a very small waste of memory allocation, we can leave it empty. And it will be, as you can expect, 0 and 5. We can use dim to change the array length. However, it created a new array and all previous items were discarded. The numbers array is a single dimension array. We can create arrays with any number of dimensions. For example, a 2-dimension array. First element, As a general rule, unless there is a good reason to use an array, you should prefer to use lists. Let's see how we can pass arrays to subs and to return arrays. So we will create a sub that finds the minimum number in an array. It expects a single parameter, which is an array, a single dimension array, and we keep the length modifier empty. We start with the first element. There is an assumption here. If someone will pass an empty array to the sub, then it will crash. And we go over all the elements, including the first one, and we check if the element is smaller than the currently smallest number. And if it is, we set it. Let's check it. And it works. Let's create another sub. This time we will create a sub that gets the number of elements and a value and returns an array filled with this value. Value will be string. This is the way to set the return type to an array. Note that this is the only place where the parentheses follow the type and not the variable name. There is no variable name in this case. We create a new array. String. This time we cannot use a for each loop because we need the index. Run it. Printed a strange string. Logging an array doesn't result in any meaningful output. We can instead convert it to a list and log the list. Now you can see the 10 elements with the value. Let's talk about lists. You can think of a list as a dynamic array. Unlike an array, which is fixed size, the size of a list can be changed. You can add new elements to a list, insert elements, or remove elements. Lists provide more features like sorting or finding an element. Let's create a new list. When a list is created, it is not initialized. We must first call initialize before we can use it. If we are creating a new list, in many cases we will assign an existing array to a list. In that case, we don't need to initialize the list. Unlike arrays, where all the elements must be of the same type, the list uses the object type. This means that you can add elements of any type to a list. It is very simple to convert an array to a list. It happens automatically. We are creating a new array and we assign it to a list. Let's try to add an element. And we get an unsupported operation exception. The reason that it failed is that list2 is a wrapper above the array we've created here. It is therefore a fixed size list. If we want to add the elements to a list and keep it modifiable, then we should do it like this. Always initialize and use add all. And we can add more items. Note that the type is not really important here. We can write it like this. When the type is omitted, it becomes an array of objects. And in the case of list, the type doesn't matter. And this time it works properly. We can insert a new item. Let's insert it as the very first item. This means that the index of the first element of the new element will be 0. We can search for elements. Six. 0, 1, 2, 3, 4, 5, 6. Now, in most cases, it is better to avoid mixing different types in a list. Otherwise, it can be difficult to work with the list. Let's say we create a new type named point. And add a few points to the list. You can see the 3 elements here. The output will be better if we do it ourselves. Now we want to sort it. As the list is made of custom type, we can use list sort type to sort it. It sorts the items based on the field name. Let's say that we sort it based on the X field. Ascending. And now based on the second field. There are other methods to sort elements. There is the sort or sort case insensitive. These methods are useful when the elements in the list are strings or numbers. Let's say that we want to get an element from the list. List get the first element. It returns an object, so we cannot do anything useful with this object without casting it. So we cast it like this. It's not a person. And here we can change. As we've seen over here, a good way to iterate over the list elements and cast the elements automatically is with the for each loop. We can also go over the items based on the index like this. Size, arrays use length, lists and the other collections use size -1. Now get the point. Now to my favorite collection, the map collection. Maps are key value data stores. This means that each element is made of a key and a value. You can get elements based on their keys, and whenever you put an element in a map, you put it as a pair of a key and a value. No matter how large is the map, it is a very quick operation to get a value based on the key. This is a very important feature of maps. Let's see a map. Map. We need to first initialize it. Now we are adding items with put. And a value. We can get items based on the key. We can check if a key exists. If we try to get a non-existent key, then it returns null. If you are not sure, then always check before you get with the contains key. Now this will throw an error. It throws an error because null cannot be casted to a number. If I was an object, then it will work and print true. The keys are always unique. If we put a new element with the same key, then it will replace the previous one. You can see that the size remains 2 in this case. We can also print the map content. As a shorthand syntax, we can use create map. Key, colon, value. In this case, we don't need to initialize the map because create map creates a new map. Let's iterate over the map content. This is done with the for each loop. We're iterating over all the map keys. And we get the value based on the key. You might see old examples that use get key at or get key value at. Like this. These methods exist for historic reasons. When B4A was first released, the for each loop was not available, so instead these two methods were used to go over the items. However, they are not available in all platforms and they are slower. Always prefer the for each loop. Unlike list, where you get the items based on the items index, the order of items in a map is not always guaranteed to be as the same order that you inserted the entries to the map. In B4A and B4J, the order will be preserved. In B4I, it will not be preserved. A map can also be useful if you want to have a collection of unique items. Let's say that we have an array with numbers and we want to find how many unique items are in the list. We'll clear the list. And the value will be an empty string. There are 10 unique items in this array. And we can see the keys and the empty values. In this case, the map is used like a set collection. We have a list with very important information, and now we want to save it to a file. We can use the file write list or write map methods. They will create a text file with the map or list content. Let's see an example. The file will look like this. This format is quite useful as it also allows you or the end user to edit the file with a text editor. It is especially useful to store the application settings, like an ini file. A list will look like here is our list. We can read it back. Note that the map order is not guaranteed to be preserved in this case. And we can read the list back. That's it. Write map and write list create text files. They are good when the collections hold numeric values or string values. However, let's see what happens if we try to store more complex objects. And we put it in a map. And now we try to read it back. And to get the point back from the map. It fails because all the values are treated as strings. The second option is to use B4X serializator, which can handle complex collections and complex objects. First, we add a reference to the random access file library. We use convert object to bytes. Now we write it to a file with and we close the output stream. There is another parameter here whether we want to append the data to an existing file, and we don't want to. Now we will read it back like this. So this line opens an input stream to the file and read everything and converts it to an array of bytes. Now we want to convert the array of bytes back to an object. Convert bytes to object. And we will try to get a point from the new map. And this time it worked properly. That's it. Thank you.